Hello, good afternoon, everyone. I know it's the end of the week, Friday afternoon, so we really appreciate you staying up to this point and listening to our talk. We have a bunch of stuff to show you, so hopefully we can keep you entertained for 35 or 40 minutes at least. What we're going to talk about today is the second of our runtime templates, so the EVM templates built by OPENZEPPELIN. So who from here knows OPENZEPPELIN, has used our contracts or any of our products or services? Raise your hand. It's OK. I don't need to do a lot of background. We've been in the industry since 2015, mainly in the Ethereum ecosystem, but we're pretty excited that we started building in Polkadot end of last year. So this is actually the second of our templates. So I want you to first meet our amazing team. I'm Gustavo, engineering manager for the team. This is OZGUN, who together with Amara and Nikita, who are our other amazing developers, have built these runtime templates. OZGUN is not very active on Twitter, so this is his Telegram handle. I'm also not a big Twitter, but you can see me posting some random stuff from time to time. So if you want to follow me, this is my handle. And also, please feel free to reach out to us using our social media, or after the presentation, we will stay around and would love to chat with you to see if you have any suggestions, feedback, or any needs for our future templates. So first of all, some context. Why do we even care? Why are we building this? Why do you need this? Why you should care about this? We know how powerful Substrate is. Like, it is an amazing framework to build your own parachain. It's super powerful. But as they say, with great power comes great responsibility. So that we know that it can be intimidating for newcomers and even for people that have been around for a while. Like, if you just put some pallets together and you misconfigure something in your runtime, you can run into security issues. So we want to achieve something similar to what we've been able to do in the Ethereum ecosystem, where people can rely on our open source libraries for smart contracts, and they can build securely from there. And we think this is even more ambitious, because this is like 1 order of magnitude bigger than smart contracts. We're trying to provide a set of templates that you can build securely from. So it's a runtime template for your parachains. As I said, this is the second one of our templates. If you were in Sub-Zero earlier this year, OZGUN and Nikita presented our first template, the generic runtime template. Since then, we've made a few changes. We've gone through an audit, and the first version of that is available today. So if you haven't tried it yet, we encourage you to do so. This template is like a base chain that you can use to, like a base template that you can use to spin up a chain. So it is unopinionated. It doesn't have the EVM. It doesn't have like DeFi use case. It doesn't have like a gaming use case. It's just the bare bone that we think you need to get started. And what we're here to show you today is the EVM template. It's built on top of the generic template, so it already uses the same contracts that we presented on that one. But on top of that, it has the EVM capabilities. And we know there are already some pallets and constructs that you can use today to build EVM templates, EVM chains, on the Polkadot ecosystem. But we have a few things that we think make this kind of unique and interesting for you. So this is our agenda for today. I'm going to quickly walk you through some of the specifics of this EVM template, why you should care, why it has some special things. Then OZGUN will take us through the most interesting part, which is some of the best practices that we're using, which we think are relevant not only for if you're building or using a template, but also for your projects, and some of the kind of bleeding edge or new stuff from Polkadot, SDK, and Substrate that we're using, or we plan to use shortly. So we want to share that with you. And then we will get to kind of the meat of this, which is a demo. OZGUN will spin up a parachain from scratch on ZombieNet locally, using ZombieNet, sorry. And will show us how you can deploy a contract from there. And we'll kind of wrap it up with some of the future steps of what we plan to build next, and ask you for your feedback. That's the more important part, I think. So EVM specifics, why are we building this template even? Like, why can't people just use what is already available out there? So first of all, we haven't built this from scratch. We're using Frontier pallets, so we want to build from a common ground. Shout out to their team. I think the work they're doing is amazing. But we changed some stuff, and we added some things that we think are really helpful. So First of all, we moved from 32-byte addresses, which is kind of the standard for the Polkadot addresses we know. But we know all the tool set and all the things in the Ethereum ecosystem, like all the things that your users want to use or your developers want to use, are built for 20-byte addresses. So we built that from day one. You have 20-byte addresses, and we provide the conversion where needed. We also are going through a security audit, so you can rely on our templates having kind of the quality and the security that you would expect from a company like OpenZeppelin. So we think that is really important. And we plan to build a lot more templates on top of that. Then we have some things for account abstraction support. If you're planning to launch an EVM parachain and you want to add some account abstraction features for your users, we have some stuff interesting for you that comes with some pre-deployed contracts that you can embed in kind of your Genesis block. So 20-byte addresses. Like I said, all the Ethereum tooling and ecosystem is built for ECDA signatures and 20-byte addresses. So we think it's important to have that as part of the template. And then we do the conversions wherever it is needed. So if you need to send an XEM message, our templates are built so that the conversion can go between 20 bytes and 32 bytes. So you don't have to worry about that. And you're comfortable and don't have like the security concerns of, hey, what happens if I'm not handling this correctly? Will it still work with our parachains? We're kind of taking care of that. Then on the pre-deployed contracts, we think that account abstraction is an amazing construct for Web3 developers to be able to provide a better developer experience for their users. And we're looking into ways to provide this even more natively as part of our chains, as part of our template, sorry. But for now, what we're doing is that we have the entry point contract pre-deployed. So you just grab the template that it's already embedded in, and you can just deploy it as part of your Genesis block. So basically, what this allows you to do is have a better developer experience for your users from day one, because you will have that contract embedded in. This is the same entry point contract that has been developed by the EF and has been audited by multiple companies, including us. So you can rely on that being secure from day one. You still need to build infrastructure for the bundlers or have a bundler that wants to do that, because that's kind of off-chain. And if you want to allow your users to pay for tokens with different currencies than the native currency of your chain, you still need to provide some paymaster implementation. But that is something that we're looking to add to this template, because we're also working to add it as part of our main Solidity library. So as soon as we have that kind of security reviewed and everything, it's something that we'll also port to this template. So you can expect to have like primitives to build some useful paymaster in the coming months, maybe like at the end of the year or beginning of next year. But it doesn't stop there. So we are including the entry point, but we're also adding like the capability for you to deploy your other contracts. So if there are any other pre-deployed contracts that you want to include, some, I don't know, maybe some contracts, some tokens, sorry, maybe some Oracle smart contracts, or whatever it is that you need to deploy as part of your Genesis block, you can use our templates to do that. The only limitation today is that you cannot deploy contracts that touch storage in the constructor. This is because of two reasons. One, it increases the complexity a lot. And two, and more important, it might incur some security risks. So if you were to touch storage, you might end up into situations that the parachain deployer, with this kind of more privileged access when you deploy the parachain, might touch storage for future accounts or future contracts that get deployed there. So we kind of want to avoid that. But if you're building on the templates and you think this is something that is blocking you and you really want it or you really need it, please reach out to us, and we are happy to work with you to find a way to see if this is possible in a secure manner. Okay, now I'll hand it over to OZGUN, who will show us some of the kind of best practices and things we're using on the templates and walk us through the demo. OZGUN, all yours.
Thank you very much. Hi, everyone. I wanted to mention some best practices that we are trying to follow and the importance of these. We are scraping through many projects for creating these templates, and many of these best practices are not followed by many of the projects. So let me first start by Clippy, and why it's important. It provides a standardized code. So which means outsider newcomers to your projects will have easier time understanding your code, which means, in turn, you will have better chance of open source contribution. Second one is Rust toolchain. You can specify this file if you do not know that, and it sets the Rust version for your project. This means that, but it works on my machine is no more of an excuse. You should expect this to work on any machine if you set the right Rust version. Especially, this is important if you are using nightly version of Rust. Rust format, again, it is good to have because it has alphabetical ordering for the imports. And usually, when you are dealing with Substrate or Polkadot, you have many imports, and trying to find some import is not a good thing. And also, nobody likes weird indentation, so why not just have it? And when you have these, you better enforce them with some CI/CD, like GitHub Actions, to ensure your project holds up to your standards. These are all minor, but the last thing is very major, so please pay attention to this. This is the most not followed best practice across the whole ecosystem. In Cargo TOML, it is widely used in the ecosystem to use branches for your dependencies. So let's say there is a crate that is not published to crates.io, like Substrate or Polkadot dependencies. So many projects use the Git version and provide a branch instead of Git tag or Git revision. The problem with that is branches are not static, so they can change in the future. The owner of the repository can push some new code to the branch, and this happens all the time. Not even our team, but many other teams have lost many developer hours due to this, because the next time they run, when they make a change to the project, it suddenly doesn't work. And the developer thinks this is not working because due to the changes that I just made, but it is not the case. The reason is some of the dependencies mentioned by branches got an update, which is to be revealed a couple of hours later. Yeah, in short, please do not use branches if you are using Git source dependencies in your Cargo TOML. The best one is to use tags. Revisions are acceptable, but tags are better. Why? Because it is less likely to make copy-paste errors when you are using tags, and developers can have easier time and improved developer experience on GitHub for checking the releases part. So I just wanted to raise awareness on this issue, and that was it for that slide. I also want to mention some new features from Polkadot SDK that we want to follow and we are following at the moment, which are proof of validity reclaim. To begin with, in short, for Polkadot-related stuff, there is a weight related to proof of validity, which is benchmarked for the worst case. So in production, usually, the required weight is not that high. And you can add simple couple of lines of code to your code base to enable proof of validity reclaim. If you do not know which codes to add, please take a note. Just proof of validity reclaim and Substrate documentation is good enough for that. You can have easily integrate that feature to your project. ZombieNet is very useful. I will show it on our demo on how powerful can it be and how to use it. OmniNode, I believe it's still not fully released, and it is still experimental, but we are so looking forward to it because it reduces hundreds of lines of node code into a couple of lines with builder pattern, which means you do not have to worry about node code anymore. It's just a dependency, and parity guys will take care of that. And usually, most of the projects have a runtime library RS file, which is consisting of thousands of lines, maybe 2,000, maybe 3,000, maybe 4,000. And think of a newcomer that wants to contribute to your project. Thousands of lines of code in a single file. This is very intimidating. So Parity is now following a new approach, which I will show shortly, that you can divide library RS for your runtime into meaningful chunks in separate files. And after that one, we will go with the demo. So let me just start with all the technical stuff. So OK, let's open a new one. All right. So for your runtime, the new method that has been followed by Parity is APIs, constants, library itself again, and this is what we made, types rs. It is not being followed by Parity. And configs. So this is another file for your configuration. I will go through each of them. So for APIs, let me make it smaller. I think it is still visible. So you see impl runtime APIs. So this thing has a couple of hundreds of code in it. So just put this impl runtime APIs into a separate file, which means meaningful chunking. We prefer to put all of our constants related to runtime into another file. This is, again, better for visibility and also for testing. So you can just export this file to your test environment, and you can test whether your constants have changed or not. This is also useful to be sure nothing is broken across changes. For the config, so all these stuff that you see on library before, that implementing the config for runtime stuff, so all this config stuff are now in mod.rs. And the configuration related to XCM palettes are in XCM config palette. And if you have, let's say we have, for example, in this case, we have configured assets palette, but that palette configuration took like long. This is like 185 lines of code for asset manager configuration. So we also put that in a separate file. So now that when you click on library RS, what you see is all these imports, and then some other stuff. And most of the important stuff have their own files. And the only thing that needs to stay on library RS is the construct runtime macro. That's it. And you have a small file right now, which is much more approachable and less intimidating. So we can, I believe, start with the demo. I have prepared a nice file, and this is live on my Notion. I believe we will put this in our documents for OpenZeppelin website. So if you want to follow that in your own practice, feel free to do so. I already did the steps that are taking time in advance to save time of yours, so I will not be cloning the repository or building the node. So first of all, of course, you need to clone the repository. Then in your terminal, move to that. Let me make it more readable for you. OK. And here it goes. So first, we will replace the zombienet config to this. This basically, in short, have two nodes in it for zombienet, which we will use. And we will build the zombienet. So let me open a terminal and copy this command. I'm already on that directory. Let me also make this bigger. So it's already built. This command has no output, so if you see no output, it's fine. It means it succeeded. I also noted the potential errors that you came across, came across. For example, this requires you to update the A-hash crate. And if you do not know, you can update individual crate dependencies with cargo update and -p command. So you don't need to cargo update and update all of your dependencies, which will be a mess. So you can just individually update your packages. And the second error that you might come across is this, which is nonsense and you can just ignore. You can just rerun the command and it will be fine. So let's proceed with the actual running for the ZombieNet. All right, you see a lot of output. I will shortly mention what's going on. So we have two nodes. One of them is Alice, one of them is Bob. And they have their own chain spec file. This is for the Bob, for example. This is the whole command for running Bob's node, by the way. And we have our local link to Polkadot.js Explorer. So the first step is to, OK, I already built the node with async backing feature, so I will not execute that step. But the next step is to copy the direct link from Alice's tab, which is here. And we will open it with Chrome. This is important. You have to open it with Chrome. It doesn't work with Opera, or sorry, doesn't work with Safari. I haven't tried Opera. And it seems to be working on Firefox, but then it creates some errors. So just use Chrome. And also in Brave, it doesn't work. So I will go to that link. And in here, we will reserve a para ID. Then we will run or deploy our parachain as a parachain in local environment. And as the second step of the demo, I will upload a smart contract to our parachain. And as the last step, we will invoke that smart chain, which is a Solidity smart chain, sorry, a smart contract, which is a Solidity smart contract, by the way. So in short, we are deploying a parachain to local environment, deploying a Solidity smart contract to it, and then invoking that smart contract. That's it for the demo. So first step is to, Network tab, go to parachains, and then go to parathreads, and you will reserve a para ID. This is the suggested para ID, and you cannot change this. You just have to take a note of this. So in our case, it will be through 2000. And we can use Alice's account. It doesn't matter. And it succeeded. So we reserved the para ID 2000 for our parachain. So next step. So this is done. So you will usually run this one, but since I already built the node in advance to save time, I will use this command. We will generate the chain spec for our parachain. So I don't want to mess with our ZombieNet, so I will open a new terminal. Let's put it in a new desktop. Let's move to our template file, all right? And we built the chain spec. This is plain chain spec, which is not usable by the node. We have to turn it into a row. But before turning it into row one, we will do some modification. The most important one is the para ID. Remember that we reserved the para ID 2000. So we will edit the chain spec with 2000 so that everything works out. OK, this is not necessary. Yeah. Let me move this here. All right. So I'm going to show off my Vim skills to prove that I'm worthy. So we will just go to parachain ID. OK, let me also make this bigger. Yeah. We will go to para ID and change this to 2. There is one more space. You can search for parachain. And again, parachain ID, change it to 2000. And you can save and quit. So that's it. We just changed the chain spec for the para ID. Name, ID, and protocol ID fields. Those are also present in the chain spec. Those need to be unique. But since I'm the only parachain that is developing against my own local setting, I don't need to change those. Same goes for EVM chain ID. So we will generate a row chain spec. This is turning our plain chain spec into a row one. And it is generated right now. And now we only have to do 2 more generations, which is Genesis state and validation code, which is Genesis WASM. So I copied that one. All right, that is done. OK, no, this is the old one. Yep, Genesis state. OK. Here we go. It's done. And the validation code, which is Genesis WASM. We need these files for deploying the parachain. I know it's a lot of steps, but since you have this documentation available online, you can just follow and copy-paste the comments, and it will be fine. So no need to worry. This is the second and last time we will interact with the Polkadot.js application in Chrome. So we will go back to here. And usually, if you are deploying against a public setting, you will click parathread. But since we are on local setting and we want to make things faster, we will go to developer, sudo, and we will select paras sudo wrapper. And in here, the extrinsic that we will call sudo schedule para initialize. So the ID field is again the para ID that we reserved. So we will change it to 2000. We already generated Genesis head, which is Genesis state, and validation code, which is Genesis WASM. We want to upload these files to here. That's why we will enable file upload. And we want to be a parachain, not a parathread. That's why we will select yes in here. So that's it. And we will just, upload our files here. Let me open a file explorer. So this is the Genesis state. Click and drag that file here. Genesis WASM, click and drag that file here, and we should be good to go. The screenshot of that is also in the documentation, so if you don't want to remember everything, this is what it should look like. OK? We will submit this transaction, again from Alice, doesn't matter from who it is. And it is done. You can see whether it worked or not by, again, going to network, parachains, and we have a parathread which will be onboarded in this time. So great. And after that, we will have a parathread running. So we can just continue with the documentation or the code. So we will use the chain spec from Bob. This is important. It's kind of complicated, so if you have more questions, feel free to reach out to me. But Alice is the first one, and Bob is the second one. So Bob has Alice's boot nodes. So in short, if you are confused, we have to use Bob's chain spec. That's it, OK? So we will go to ZombieNet once more. Where is that? Here. And you see that for Bob, this is the command for Bob's node. We will just need the chain spec of Bob. And this is here with chain, -- chain, and the Rococo local JSON file. This file is regenerated every time you run ZombieNet. So if you copied it and you stopped the ZombieNet and you restarted it, it might not work. So be sure to copy this one every time you start your ZombieNet. OK, so is this locked? Yeah, no. OK, so I will just take a note of that chain spec here. I will edit the nonsense from like terminal stuff. Just delete those empty spaces. And here we go. We have Bob's chain spec copied as a subcommand. I will modify our node command in here. Yes, so this is the node command for our parachain. I copy that, and I can run our node. Before that, let's be sure if our parathread has been onboarded. Yes, it is onboarded. And as you can see in the overview, we have a parachain with ID 2000, which is exactly what we wanted. So if I run the node now, I should be expecting block production. Everything seems fine so far, and it imports. That's also a good sign. And great, we are preparing blocks and submitting them. So node is working. So we basically right now completed the first step, which is the longest one, which is deploying the parachain. OK, so we got that covered. So the next step is deploying smart contracts. I already have Foundry installed, but if you don't, again, you can install it with this command. And I already have the necessary Solidity file and the JavaScript project for that. So I don't want to use some external tooling. I just want to use Foundry and regular Web3 library for JavaScript. That's it. So I will quickly show you the files. OK. So in Hello World, we have a very smart, a very simple smart contract which just prints out Hello World. That's it. And we have a sanity check JavaScript file which tries to get the balance for Alice and signs the transaction. So this is sanity check. This is not related to smart contract. This is just for whether our parachain is EVM compatible in terms of accounts. So let me just try that. OK, so we got a non-zero balance, which is great for Alice. And if you wait a bit more, we will get the details for the transaction. Sometimes it can take long. Yeah, we got it. I will make it bigger. So you have everything related to the transaction, the hash, index, block number, etc. Which means our parachain is EVM compatible in terms of accounts. And the next step is, let me go through documentation. Oh, sorry, for the files. Let me go back. So we will have another JavaScript file which is to call or invoke our smart contract. This is just this is the port for our node's EVM RPC. And this part is the address that your contract is deployed to. That's it. Again, very simple. And lastly, this is the last file, we have the ABI for the smart contract, which can be which you can generate from Foundry command. So I already have that generated, so I paste it. But the command for that is this, like forge build, and this is just generating the ABI for your smart contract. Before that, we want to deploy our Solidity smart contract, which is with this command. This is, again, the RPC for our node's EVM end. And this is the private key for which the account will pay for the fees. So this is the private key for Alice. We already extracted that and put it in our command. So I will just execute that. Let me run this in VS Code. No, yeah, another terminal. So let's open a new terminal. This time, developer, Web3, yeah. OK, so it compiles, and then it will deploy the smart contract to our parachain. If you wait for like 10 or 20 seconds, it should be done. Here we go. In here, you see it's deployed to this address. So you just copy that. These are all documented in the Notion guide that I put. So don't worry, don't try to memorize them. It will be online. And you will just want to replace this address. OK, let me make it like this. So I just modified the contract address. That's it. And now I will invoke this JavaScript file, run it. Let's clear this. And if I say node invoke smart contract.js, you see hello world is printed out. We successfully invoked our Solidity smart contract in a Polkadot ecosystem. So that's it for our demo. Hope you like it. I will hand it over again to Gustavo to continue with the presentation.
Cool, thanks, OZGUN. This was really nice. I hope you guys enjoyed it, and hopefully we're making your lives a bit easier to deploy a parachain. And our goal is to keep working to make it even easier. That's why we're also working with some of the amazing teams building in the ecosystem. We have already worked with the Rock team on having a POP CLI integration. They did an amazing work, and now you can use these templates from POP CLI. So I think the generic template is available, and they are integrating the EVM one, and that one will be available as something you can use for more serious cases for productions. One, it's audited. The EVM template is audited. It's being audited as we speak, so we hope to launch that near the end of the month or the beginning of next month. So keep an eye on our repo for that. We are also...
Sorry to interrupt, Gustavo. We just had a discussion with POP CLI before this thing, and we showed them our demo, and we are trying to make it possible for, like, you see how many steps were there in demo, right? Like, there were many. And imagine if you can make this work with a couple of commands from POP CLI. It will be probably possible. Like, deploying the parachain to a local environment is already possible with POP CLI, and they are trying to import the steps for deploying the Solidity smart contract and invoking it as well within POP CLI. So probably in the future, in a couple of months, all you have to do is running some commands with POP CLI. Sorry for the interruption, please.
Oh, cool. That's good. Good explanation. Yeah, the integration is amazing, and we hope to make it better. We're also in conversation and going to start to work with the Tansy team so that you can also do this through kind of a nice UI and leverage their infrastructure and all the amazing work they are doing. So keep an eye for that. That's something we plan to do as part of our next milestone. And we're starting to think, like, what should we do for our next templates? Like, for now, the clearest use case that we've seen is building on top of this EVM template some DeFi use cases, but we will ask you for your feedback and ideas if you have around this use case or others. So some things are like, we know how powerful XCM is, but how kind of painful it can be to construct these XCM messages. So we're thinking of providing some abstraction on top of that, maybe, that allows you to tap into a liquidity of protocols that have like these larger DEXs volumes that you can tap into. Another idea is bringing like some precompiles for elliptic curves that are not easy to build in Solidity today, but could be part of your parachain precompile. So an example of that is SCP-251. 6 or 1, sorry, I always have a trouble saying that, so that you can improve that account abstraction experience that we were talking by allowing your users to sign transactions with the secure enclave from their iPhones, for example. Yeah, we have other ideas that we would love to chat with you. So, and the idea is to keep building these amazing templates from the feedback from the community and making it easier and easier for people to spin up their parachains or app chains or however you want to call them. So thanks a lot. I hope you enjoyed this. This is the QR for our repo. If you want to scan it, we want feedback. That's the most important thing. So please submit issues, PRs. We'll be around for a while. So contact to us if you have ideas around DeFi templates or anything else that you would like OpenZeppelin to do in the Polkadot ecosystem. We'll be around for a while. I think we might have some time for questions. I don't know. Yeah? Cool.
So this is going to be a very granular question for you guys. I viewed what you were doing and read the proposal and everything prior to coming to Decoded. I was actually looking at it for promotion and for this event. And when I was really excited about what you did here, because one of the things that I heard a lot was how difficult it was to do this function, right, to put up a parachain. So my question is, does it bring it all the way up to a technical standpoint where like this would have been very useful for Mythical? Or is this like a more basic bare bones that you then have to build upon? You know, like I said, a little bit of a granular question from a non-developer here.
Yeah, great question. So today, it's more of something that you would probably build on top. So we only have the generic and the runtime template and the EVM templates are available. So unless you have like a very unbiased chain that you want to deploy, that you could do that, like, and it would work out of the box. But if you want to build something more specific, more app specific, you would use the template and like clone the repo or use pop CLI or whatever you want to get started, and you could build on top. But what we want to do is once we have these foundations, start building more app-specific use cases. So that means DeFi templates, maybe at some point, like, I don't know, gaming templates. We're still looking into it. So that's what we also want the feedback and seeing what are like the biggest use cases and kind of the pain points from the community. I hope that answered the question.
Hi, thanks for the presentation. I think it's amazing, very useful. Do you plan on integrating some like features that some famous projects like Moonbeam did? For instance, the possibility of treating the XCM bridged assets like ERC20, they call them XRC20, or the possibility of, for instance, of having an equivalence between the Ethereum account and Substrate account, so to offer a unified view to the user? Thanks.
Should I? Can you repeat the question? It was a lot. I forgot the beginning, sorry.
If you plan to integrate some other customization that other EVM parachains did, for instance, Moonbeam, that are very useful. For one, they have the possibility of treating XCM bridged assets like ERC20, so it's very useful, so you can immediately bridge them elsewhere. Yeah. Or having like a kind of equivalence between Ethereum and Substrate account, so you have a unified source for all your liquidity and so on.
Yeah. We talked about it, and for ERC20 tokens, for example, we paved the way for paying the EVM gas fees with any ERC20 tokens thanks to Paymaster palette. And for all the other things, yes, you said, they are all on the table. If there is enough feedback and market validation, we are more than happy to improve everything in the template. So feel free to open an issue in our GitHub that I want this feature, and we will for sure do it.